this video I'm going to go over some atom economy calculations. So atom economy is used in chemistry and it's a measure of how many atoms from a reactant end up in the desired product. So if we do some examples, we have glucose and it's converted into ethanol and carbon dioxide. The equation looks balanced, so we can go ahead and find out the atom economy. So to calculate atom economy, you divide the MR of the desired product over the MR of all the products. So our desired product in this case is ethanol. So we do 2 multiplied by 2 times carbon, so 2 times 12, which is 24, plus 2 times 5 times 1, because the MR of hydrogen is 1, plus 1 because we have a hydrogen here, plus 16 because we have an oxygen here. So that's all divided by this amount. So I'll just put MR of ethanol plus the MR of carbon dioxide. So we'd have 1 carbon plus 2 oxygen, so 32. So the atom economy for this top equation is 2 multiplied by 24 plus 5 plus 1 plus 16. So that's 92. So we have 92 on the top, and we need on the bottom we need the MR of ethanol, which is 92, we've just calculated, plus 2 times 12 plus 32. So the atom economy of this equation is 0.51. It's usually given as a percentage, so it'll be 51%. If we do more examples, we have magnesium oxide, hydrogen sulfate, sulfuric acid, magnesium sulfate, and water. So in this case, the desired product is magnesium sulfate. So we'll do MR of magnesium sulfate divided by MR of magnesium sulfate plus MR of water. So the MR of magnesium sulfate is 24 plus 32 plus, and we have oxygen up here, 4 times 16. That's all divided by this, so MR of magnesium sulfate plus MR of water. So hydrogen is 1 and oxygen is 16. So this would be 16, 17, 18. If we calculate that, we have 24 plus 32 plus 4 times 16, 120. So 120 is the MR of magnesium sulfate. 120 over 120 plus 18. So the atom economy of this calculation, of this equation, is 0.8696. As a percentage to two significant figures, we have 87%. So comparing to our previous example, this one has a higher atom economy, so more of the reactant is going into the desired product. The last example, we have iron oxide, carbon monoxide, iron, and carbon dioxide. So in this case, we want iron. So we have 2 multiplied by 56, all divided by 2 multiplied by 56, plus, so 3 multiplied by carbon, which is 12, plus 2 times oxygen. Oxygen is 16. So it's plus 2 times 16. That gives us 2 times 56 over 2 times 56 plus 3 times 12 plus 2 times 16, which is 0.456. So as a percentage, it would be 46%. And that's it. That's how you calculate atom economy calculations.